for the letter R. You would use this part of the video only if you get stuck. You could work on your own and do the letter R. I'm defining R. Then I'm going to turn it to the left 90, then forward 100, then right 90. And let's go forward 30. We're going to go up and over, and then we're going to start to draw a semicircle. We have something for the turtle called circle. If we just put in circle and we put in 50, it will draw a circle with a radius of 50. Let's try that. So we'll just put in the R here. It's going to do R and function F5. Let's try that without the goto. It's making the circle in the wrong direction. It's making the circle in the upward direction. I want to make it in the downward direction. To make it rotate one way or the other, we just have to change the sign of the radius. Let's make that negative 50, save that, and then function F5 to run. Like that. Radius is 50, makes the diameter 100. I want the radius to be 25. I want it to only make a half a circle. If we tell it the ending angle to be 180, it'll stop there. Let's do circle 25 and 180. Let's see how that works. Save that and run that. That's the part of our R that we want. Then we want to rotate left 90 degrees would be straight down. We want to go a little bit further than 90. Let's try 120 degrees. And then we want to move downward. Now we're at 50, right? If this angle is 90 and 120 is 30 more, we have a 30-degree angle here. You could use your trigonometry to figure out how long the hypotenuse of this triangle is going to be. You could just use your knowledge of triangles. So if you have a 30, 60, 90, that's half of an equilateral triangle. We know this distance from here to here. We know we want the end of the triangle to end up about here. If we know these distances, we could calculate, you know, the height and you know how far we're moving over. So let's say you had an equilateral triangle where this was 60, 60, 60. That would be the same as this, would be the same as that. If we're talking about a 30, 60, 90, okay, so we know that the height here is 50. Let's call this x from here to here is x, which is going to be half of this. Double the x is going to be, this side is going to be 2x. We know that c squared is equal to a squared plus b squared, where the hypotenuse is our c, the short leg is our a, the medium leg or the longer leg is the b. We end up getting c squared is 2x, so like square the 2, square the x, 4x squared is equal to a squared, which is x squared, plus 50 squared. Square the 5, 25, double the 0, 0, 0. Subtract x squared from both sides, we end up with 3x squared is equal to 2,500, 2,500. Divide by 3, so x squared is equal to divided by 3, 833.3 repeating, and then take the square root. X is equal to the square root of 833.3 repeating, 28.86. We want double that for this length. Times 2 is 57.73. I'm just going to copy that. This length is 57.73. Back into our Python. We are facing that way. We want to turn left 120. Then we want to move forward 57.73. Let's see what that looks like. That looks fine. Then we want to turn to the right, the opposite of what we moved to the left, 120 degrees. Then forward 20, right 60, I think. And then let's go forward the 57.73. That should be 60. Save that. Function F5. That looks a little bit better. I'm too close over this way. If I came down, the thickness of this wouldn't be 20 pixels wide like this is. We can use trigonometry to figure out how far we are. We could ask the turtle where it is. We can use something called x-coordinate. We can tell it to print the x-coordinate, turtle.x-coordinate. Let's see if that works. Function F5. And we're at 9.9, so let's say 10. We're at 10 pixels. We want to be at 20 pixels. So let's move this, when we do this step, let's just move it 10 pixels further than we're moving it. Right now we're moving it 30 pixels, so we'll just go to 40 pixels. And that should fix everything. Up here where it says 30 pixels, we'll go 40 pixels. Function F5. Now we're at pixel 20. And then we want to turn to we're starting at 0, 0. We can ask it that. We can tell it to print our coordinates. The command for that is, we can ask it its position. Like that. Let's see how that works. Function F5. It said our position was originally 0, 0, and now we're at 20 pixels over. So I'm just going to turn, if we turned it 90 degrees, it would be this way. So 90 plus 60, 150 degrees straight down. Let's try that. Turn left 150 degrees, and then forward 50 pixels. Let's turn to the right 90 and forward 20. We need to pick the pen up. And to go up here, forward 20, we will pen up. Let's go back 20, right 90. We're here, we're going up, we're going to go up to 50, and then 20 more, 70, forward 70. Pen down, forward, I think this is going to be 20, because this is 50, so we've moved up 20 off of 50. 70 might be too much. Then pen down, forward 20. Let's see what that looks like. Let's turn to the right 90. We'll go forward a little bit, and then we'll repeat this little half circle. Right 90, and forward a little bit. Let's try forward 10, and then we'll do our circle. So we're moving up 20, the radius is going to be 10. Let's try that. This looks good, it's just we're a little bit high with that. Let's just finish this off by moving forward. Let's move forward 10. That finishes that all off. I want to lower this a little bit. So when we did the pen, we came forward 70. Let's go forward 65. And that should center this thing. We need to go further forward a little bit with that as well. Let's just see what that looks like, and then we'll correct. This looks a little fat here, so I'm just going to drag this forward, maybe 5 pixels. Right, 90 forward 10. Let's try going forward 20, which will probably be too far. Save and run. 20 was too far. Maybe 15. A little bit of trial and error here. We want to get the pen right here, so it's ready to write the next letter. Have it turn left 90, move down this distance, which we know now is 65, then turn left 90, move forward this distance, which we could figure out. Remember, this is a 30, 60, 90. If we doubled it, we have an equilateral triangle here. We know this distance. We know that this is half of it. We've already calculated that. From here to here, we know is 28.86. If this is 28.86 and this is 20, this is 48.86, and then we want to move another 20, so 68.86. Turn to the left, pen up, left 90, forward 65, left 90, forward 68.86. We'll save that. Function F5. And we're ready for our next letter.